Professor Gavor here. It's already week 6. I can't believe there's like 2 weeks left. This quad has just zoomed by. And for the most part, you guys have been fantastic students. I've enjoyed having you in this class. I wish we could have had a few face-to-face sessions. I always like that a little bit more, but online also works very well. We're moving in, if we look at this class, the first 2 weeks were kind of like model building. Actually, the first 3 weeks were model building. We did linear cost, revenue, profit problems. We did a little bit of statistical modeling. The next week we did decision analysis and built models for making decisions. And then we did inventory analysis. So if the first 3 weeks are model building, the next 2 weeks, regression and other forecasting techniques, were a forecasting module. And now we're doing a linear programming model. And it's chapter 7. And you'll see that there is a PowerPoint video, of course, as we have. And then there's linear, so these are the materials to review. Linear programming, statement formulation, and solving. And if you look at it, it's the problem statement, how you formulate it. And basically, I would watch this, go through this after the lecture. And there's the file that goes with that write-up. And then here's what's going to be critical to you for your homework. There's YouTubes. Using Desmos to solve a linear program. Using Solver for linear programming. Using Solver for linear programming part 2. I'll let you, QM uses Solver, but I don't have a video for using QM. I think you can almost figure that out. If you could do the using Solver, you could use QM. It's almost the same kind of thing. And the textbook provides plenty of examples on that as well. So you're going to rely on these videos. The discussion is, what is this thing, linear program? You're going to watch a video and find out what it is, but it's basically constrained optimization using all linear functions. So that's why when we write about Goldratt, the theory of constraints, we learn about constrained, which constraints are dominant and which aren't, and what that means. So it leads from that paper as well. Here's the assignment. And you can already see several of you have dutifully gone ahead and started it. So do a literature search for an application of linear programming from the Brandel Library website. Choose an article or paper of interest to you. Post the title of the paper here by Saturday. I don't know, Saturday. By Saturday morning. That's when the class ends on Tuesday. So let's say by Wednesday of this week. There can be no duplication. If someone has already posted the paper, you must choose another. Attach a PDF or web link for the paper. Summarize the paper in a few hundred words in a thread you established by the 15th. Comment on 2 other students' posts by Sunday. And again, it's worth 25 points as usual. So let's save this. And it's due this coming Sunday. Now, with due dates being flexible, well, how flexible are they when the class basically ends the week of May 4th? So you don't have a lot of time to be flexible. That's why people like Jeannie and Madeline and Bethany and Elena are already on top of it. So they went and found their article and posted it so no one else could post it, which is a smart thing. Here's Madeline's giving a summary. I'm not sure what the nature of her article is, but application of nonlinear programming in apple orchard pest control. Non-linear programming, we're doing linear programming, but it's still mathematical programming, it's still constrained optimization. I'll go with it. But if you pick something too esoteric, if you have no idea what they're talking about as you start reading the paper, because sometimes they can be pretty mathematical. Let's open this up. It's about horticulture, how, and a spider mite. Things keep me awake at night. You see that they're talking about setting up the mathematical program, and they go through a mess of stuff. I don't expect you to understand all of it. This is blessedly short for one of these kinds of papers. So you want to get a feel for what they're talking about and the application of this mathematical constrained optimization kind of program. And I'll see how Madeline summarized it. I'm sure she, given her track record, she did pretty good. And sorry for featuring you in this video, Madeline, but thank you for posting early. Okay, the homework assignments. Week 6, Chapter 7. Do 7, 14, and 15. They're separate problems via the graphical approach using Desmos. I don't care what the problem itself says. I want you to use Desmos to solve this. And you saw there was a video using Desmos to solve a linear program. 714 is really easy. 715 gets a little bit harder. In 716, formulate the problem and provide the solution using QM, the textbook software, or Excel solver. I don't care which one you use, but if you want to use QM, use QM. In 717, I want you to formulate the problem, provide the solution using Excel solver. No QM. Okay? Only 4 problems. The first 2 are worth 12, the next 2 are worth 13 each, adding up to 50. So you can do this. Let's go back here and do a preview of next week. And maybe I'll do a preview of next week if I could scroll up. All right, Chapter 8. There's a video. You want to watch this. Probably watch this video even this week. Can't hurt you. Well, it could hurt you because the guy that's giving the video is pretty boring, from what I can tell. All right. The discussion 7, easiest discussion you will ever have. What will you retain moving forward? What methodologies do you think you will retain from this class that you may actually use in the real problems in your real work? What concepts do you think you will retain from this class that will help you be a better manager in the future? Like maybe just teaching you a way to think, and then provide suggestions to improve the course, including, get another person to teach it, maybe. Let's see, self-deprecation, I guess. The textbook problems, now we're going to work on harder problems. So I want to go through here and I'm going to assign you problems. It may not be the same problems I assigned these guys. That was from the last class. So there's 14 of you, teams of, there'll probably be teams, I have to come up with 7 problems. Let me know, everybody, if I say, let me know if you want an easy problem. Let me know if you want a difficult problem. And I won't hold it against you. Here's the way this works. You're going to work in teams of 2. You have to do just one problem. That's the only thing is for 50 points. But it's more extensive. And you'll see when you look in Chapter 8 how extensive some of those problems are. First, formulate the linear program. This is to be done using equations and inequality, handwritten. You want me to check it out before you even attempt to put it in Solver. That means you're going to have to schedule a meeting with me on Microsoft Teams as a team next week. I don't want to meet with one. I don't want to do it by email. I want to do it by Microsoft Team. And you got to show your faces so I can see who you are finally at the end of the class. Do this on pencil and paper. You can send that to me, but we'll go over it. Next, once I have approved you for that, upon my approving step 2, formulate the problem in Excel so you can use Solver to solve the problem. Send the solution to me, and we'll have another little meeting that week on Microsoft Teams. Both team members together. Got to be that way. And you got to show your faces again. I assign the teams, I assign the problems. I used to make it, hey, you pick your own teams and you pick your own problems, but no, it's easier this way. It just takes less time. And I will check your answers and tell you if you did it right. So it's impossible to get less than 50 points. The only way you get less than 50 points, because one, I check your formulation, I'm your $250 an hour consultant that's not charging you, is, so did you formulate it properly? Yay, good job. Did you then put it in Solver? Yay, good job. Everybody says, no, Solver's not working. Well, no, there's a mistake. And we dig through and find out where the mistake is, and you go, oh, yeah, I see it. Or you see it yourself and don't need me. And then you have the answer. So you either get 50 or you get 0, like you didn't do it at all. So that's what we're going to do. And when is that going to be due? May 3rd, we did say that. So let's save this bad boy. And I'll make the team assignments at the end of probably this week. The last thing is a paper. Well, you can write a report. It's an extension of the other assignment. It's still 2 of you working together on a team, and you're basically going to write up a report for the problem that you did. Like, I'm your boss, and you solved this problem. What do we do? And I might give you the option of creating a PowerPoint video. Like, I've created all these insomnia curing videos that I've made in this course. You can make a video if you like. It's got to be 2 of you, and I would use Microsoft Teams to do it because you could share a screen and you could both be talking at the same time. And if you do a video, you both got to talk. A lot of times what happens is someone's stronger mathematically. They take the lead on the mathematical program, and then that person says, well, I did 60, 70, 80% of the work on the mathematical program. I think you should do 60, 70, 80% of the work on the paper. But that's up to you guys to decide how you do the work. But you could also do a PowerPoint. I think if that's easier for you, but creating the video could take a bit of work. I'll make both options available. And I will prep this more again next week. So that's all I got for you now. Let's finish this thing strong. Happy to give you all great grades in this class. And thank you very much for paying attention.